Hi everyone, in this video we're going to go through the derivative of e to the power of x. So this is probably one of the more simple derivatives to find, because as you can see in this little purple box up here, the derivative of e to the kx is just k e to the power of kx. So, oh gosh, come on. When we're doing question 1, it's not going to take us too long because it's pretty straightforward. In question 2, I'll show you how to use the chain rule, but as you can see in this little green box, we're just finding, instead of it being k, we're finding the derivative. And then when we get to question 6, again, we're going to be, it's similar to what we were doing in question 3, so using the chain rule. And I think that is it. So let's start working through them. So let's start with an easy one. So let's do A, and then we'll get into probably D, E, and F, I think. All right, so question A, we've got e to the power of 5x. So basically we're taking the derivative of 5x, which is just 5. So the derivative is, so d dx is equal to 5e to the power of 5x. So if we just have a look back up at our purple box, you can see that your derivative is, all we do is take that coefficient of x and multiply that by e, but that power stays the same. All right, now looking at d and e, you can see they're fractions, but we can just write that denominator as a negative power. So we've got, oops, d, it's about to write b, e to the power of 2x, and my dog has just come in the room, shaking her head, sniffing around, negative, oh, now she's distracted me. All right, plus 1, just make sure I've written that because I think I was getting mixed up with another one, and e to the power of x. Now remember, when you've got a power on your denominator, if you want to bring it up, nearly up to the next question. If you want to bring it up to your numerator, it just becomes a negative power. So e to the negative x, and then we're just multiplying everything on the denominator, sorry, on the numerator by e to the negative x, but I'm just going to put it in brackets first so you can see what I'm doing. All right, so when we multiply through, remember your bases stay the same and we add our powers. So negative x plus 2x is just x. Then we've got e to the negative x plus x is 0. And then we've got plus e to the negative x. So what we're going to do is everything individually. So e to the power of x just stays as e to the power of x. Now, e to the power of 0, anything to the power of 0 is just 1. So that actually disappears. All right, so I might just underline that. So that is equal to 1. Okay, so the derivative is 1 is 0, and then we've got minus e to the negative x. So that's your derivative, just making sure you put that denominator up the top. Now, if you have to, I'm just thinking about what the answer will be. You might have to write that as e to the power of x minus e to the power of, 1 over e to the power of x. Right, so instead of having a negative power, writing it as a positive power. All right, let's do another one. So let's do e, another practice of one like that. 4e to the power of 2x minus 2e to the power of x plus 1 all over 2e to the power of 2x. All right, so again, bringing that, if we want to bring that 2 up the top, sorry, not the 2, oh my gosh, that 2 does make it difficult. We can bring it up with a negative power, but what I'm going to do is, oh gosh, what am I going to do? Many ways you can tackle it. I'm going to take out 2 as a common factor, first of all, on the top. And that 1 is going to become a half over 2e to the 2x. So they actually now cancel out. And then I'll bring that e up. It's e to the negative 2x, e to the 2x minus e to the x plus a half. All right, and then multiplying e to the negative 2x by everything inside the bracket. So e to the negative 2x times e, actually. I'm going to come back to this. Oh my gosh, I can't believe I did that. Where is my derivative? All right, so my derivative is this one, isn't it? Yes. Sorry, I didn't write that before. So I kept writing equals, but we had to do the derivative, I've just realized then. All right. So multiplying through, so we're going to have e to the power of 0. Then we're going to have minus e to the power of negative 2x plus x, so negative x plus 1/2 e to the negative 2x. All right, so we're going to find the derivative now. I can't believe I don't have enough space. D to the d dx. So we're finding the derivative of each term. So the derivative of e to the power of 0, which is 1. So remember that is equal to 1. Anything to the power of 0 is 1, so that disappears. Then we're going to have that negative times the negative, so it's just going to be positive e, negative x. And then our second one, we've got negative 2 times a half, which will make it negative 1. And then e to the negative 2x. And let's just write them with positive powers. Like so. Just looking at the last one, doesn't look too difficult. So I might just leave it being those three for now. All right, I did just pause to check the answers, which is always a good idea. So you can see they've left the answer for D with a negative power. All right, so just be conscious that your answers in your textbook might differ to what you've got. Don't automatically assume that you're wrong. So I think it's a good idea to write it as a positive power. So just, yeah, take note of that. And looking at E, now they've taken out e to the negative 2x as a common factor, which is a bit weird. So when we multiply that through, we actually get the same answer, which is good. All right, moving along. Let's move on to question 2. So I have put there that you're basically using the chain rule, but you can see you're just taking the derivative of whatever your power is. So I might just show you one using the chain rule, and then we don't have to always use the chain rule because it's a lot of work, which is unnecessary. All right, let's have a look at C. Oh, actually, I'll do D, just because it's a bit longer. E to the x squared minus 2x plus 3. Now, notice how I clearly write my power up the top. Please don't be sloppy with that, because you will be marked incorrect if it's not quite obvious that it's a power. I mean, on your exam, that is. Okay, I might be a little bit more generous. All right, so we're going to let u equal that power. So let u equal x squared minus 2x plus 3. So du dx is equal to 2x minus 2. And that means y is equal to e to the u minus x. So then we've got, oh, actually, sorry, I might leave that x off for now. I'm just going to do the derivative of the e. So du, hold on. du. I'm not functioning too well today, girls. E to the power of u just stays as e to the power of u. Now, when we bring them together, we're going to have dy dx or d dx 2x minus 2 times e to the power of u. So u is x squared minus 2x plus 3. And don't forget that x, so that x becomes minus 1. Now, you'll notice that basically, if I just get my highlighter so I can show you, this 2x minus 2 is just the derivative of this. So we don't actually have to go and do the chain rule. It's going to work every time. All right, so let's go and do a different one. So I might go back and do C. So we've got e to the power of x squared minus 4x. Then we've got plus 3x plus 1. All right, so we don't have to let u equal x squared minus 4x. All I need to do is find the derivative and multiply e by it. So it's going to become 2x, and I need to write d dx. So the derivative of x squared minus 4x is 2x minus 4. Just make sure you put that in brackets because that's multiplying, both terms are multiplying e, and then your power stays the same. Plus the derivative of 3x is 3, and then the derivative of 1 is 0. All right, just looking to see, let's just do e. It's because we've got something a little bit different. So e to the power of 1 over x. It does say x can't equal 0. That just means because if it was equal to 0, then it would be undefined, that power. Okay, so that is the same as e to the power of negative, what am I doing? X to the power of negative 1. All right, so if we were to take the derivative of that, so d dx, taking the derivative of x to the power of negative 1 is negative x to the power of negative 2. And then it's e to the power of 1 on x, if you want to write it like that. And I probably should write that x to the negative 2 with a positive power. So it's going to be 1 over x squared times e to the 1 on x. The reason I wrote times there is so we can clearly see we can write that as one fraction. All right, moving along. So in question 6, we are going to be using the chain rule, especially for A. I'm just wondering if we're using the chain rule for actually, I'm not using the chain rule for all of them. So we will for A, not for E. We will be for C, not for D, not for E, and not for F. All right, maybe we'll do all of them because they all look quite difficult here. Okay, so let's start with A. So we've got e to the power of 2x minus 1 to the power of 4. Now, we'll use the chain rule here. I think I said that before. So let's let u equal e to the power of 2x minus 1. So du dx is equal to 2e to the power of 2x, and then negative 1 goes. So let's let y equal u to the power of 4, so dy du equals 4u to the power of 3. So we're just using the chain rule, so hopefully you've done the chain rule section. So our derivative, let's just do dy dx is equal to 2e to the power of 2x times 4u, so just put that in brackets. Remember we defined u earlier. All right, bring it all together. So 2 times 4 is 8, e to the power of 2x, then e to the power of 2x minus 1 cubed. All right, let's do another one. Do b up here, e to the square root of x. Because I feel like my voice is very boring tonight, so it's, I apologize. All right, so we've got e to the power of x to the power of a half. Okay, so we're finding the derivative of x to the power of a half. So I'm just going to write my d dx. So that's going to be a half x to the power of, so we're reducing our power, so negative a half, and then e to the x. And because I had squared root, I'm going to write square root there. Let's just tidy this up. Oh my gosh. Where is everything going to go? All right, we've got e to the square root of x on top, and then 2 root x on the bottom. Now, you could rationalize the denominator. I wonder what the answer actually, how it is in the textbook. But the x is to a negative power. That's why it's gone down the bottom, and it's to the power of a half, so it's a square root. the 2 is already on the denominator, so that's down there, and it's multiplying e to the square root of x. So let's see how the textbook has put that answer. All right, question 6. What's that, 6a? 6b, I think it was. All right, so you can see it's multiplied the e to the power of root x instead of putting it on the numerator. Same thing if you, yeah, same thing. All right, let's move on, excuse me. Okay, question C, we're going to use, actually what I might do is I might just write next to it because you can use the chain rule. I don't want to keep doing ones that you can probably easily do on your own. So remember the square root is the same to the power of a half. So you let u equal e to the power of x minus 1. Let's skip to e because d I feel like you can do. All right, let's do e. So we've got e to the power of x minus 1 times x minus 2. Now, the easiest way to do this is just to expand those brackets. So we're left with e to the power of x squared minus 3x plus 2. So the derivative of that, we're taking the derivative of our power, so that becomes 2x minus 3. Make sure you put that in brackets. E to the power of x squared minus 3x plus 2. All right, and we'll do f, just because it's an interesting one. E to the power of x. All right, so the derivative of e to the power of x is just e to the power of x. So we're going to have e to the power of x times e to the power of x. I'm curious to see how they've written that in, and I should write d to dx. Whether they've multiplied, because we've got the same bases, I wonder if they've written e to the power of x. Let's have a look. F. Oh, there we go. Oh, plus x, yes. Oh my gosh, don't know my index laws. Let's go back. Yes, it is plus. Quickly rub that out. Yeah, we add our powers when we multiply the bases. Okay, x plus e to the power of x. Awesome. All right, I think that's the last question. Okay, and then we'll move on to 9H. Bye, guys.